The beauty of it, like we were talking about earlier, light waves do not emit EMI. So therefore, now I don't get any noise coming between my two channels. And so we can send these signals down this backbone. So we're increasing the capacity of the fiber. More importantly, as I think about autonomous vehicles, one of the analogies I draw is it's not too dissimilar to the human body. What we've been focusing on with autonomous vehicles is the autonomy part, right? That's the brain. That how do we make decisions? But the reality of the human body, just like you and I are sitting here talking, is the fact that we sense things, whether it's by touch, whether it's by smell, by feel, and all of those sensors are then transmitting signals back to our brain through our nervous system and our spinal cord. What we do is kind of like the spinal cord, right? If you imagine all of these sensors at the edge of a vehicle, all of them are coming back to the CPU some way. Well, instead of having 20 different strands of fiber coming back to the CPU, we do all of that on one strand of fiber. So we've got these touch points that reach out. They come back, we can combine all of that onto a single fiber, transmit it to the CPU, undo it at the other end into the 8 or 10 different signals. And so it's no different than if you had 10 or 20 connected, but the reality is you're doing it with one strand. So we've been able to carve out our space. As I talk about it, it's our moat, right? We built ourselves a moat that makes us unique. There's only a few companies in the world that can do what we do. And the reality is most of them use more of the brute force method of saying, I'm just going to take one laser, one signal, and one fiber, and I'm going to transmit it to the other side. And if you want two, well, that's two lasers, two fibers, boom, you're done. And if you want 10, right, you see how it scales. And that's what we do differently. We do not do it that way. We combine all of that onto a single fiber.